Hi, welcome to my channel. I've made a video on optical phenomena. I hope you like it. Please do not forget to share, subscribe, and like. Okay, so now this topic is about optical phenomena. So we need to basically look at all the illusions that are there. So it's a very small topic, like a 2 or 3 minute topic. So we'll just complete it very quickly. So I've created a presentation already for you. So there's an inferior mirage. So it is an illusion on the hot desert where looking at the hot ground, it gives reflection of the sky. So if you can see in the image, it is giving the reflection of the sky here, right? So this is what an illusion is. This is what an inferior mirage is all about. The reason for this is the lapse rate. You can read about it in detail if you want to understand how that effect really happens. Then we talk about superior mirage. Here what happens, it's an illusion on the cold ground. So basically air below the line of sight. So if this is my line of sight, right, so the air below this, there is a ship, it looks like it's flying in the air, however it is not, it's on the water, but due to the air being colder in my line of sight is colder than the air above it, so this is the illusion that I get that the ship is flying. Okay, so this is how it is. This is a superior mirage. Great. Now this is very important. So these two questions might come and they normally come. So there is Aurora borealis and there is Aurora australis. Okay, so these are the northern and the southern lights. So how do you remember which is the northern lights and which are the southern lights? So you can remember it with the help that Australia is in the south. So you know that is how I learned. So these are the northern lights and these are the southern lights. So the questions would be like which are the southern lights, which are the northern lights. They'll give you options. Okay. So these are the two kind of illusions that you see in the sky. You can also look up to on Google on these sky images. They're very pretty though. And then we talk about bishop's ring and halo phenomena. Okay, so these are very similar. There are few differences. We'll figure that out because the questions would be according to that. So bishop's ring, it's a ring of 22 degrees. Okay, due to diffraction. The reason is diffraction of light. If you don't know what diffraction is, you can always read up to it. So it's a physics phenomena that you must have done in your 12th. Okay, that is diffraction of light due to dust particles in your AS clouds. Okay, so altostratus clouds. So we'll read cloud in the next topic. I'll make a video on clouds, so we'll know what these clouds are. So this is altostratus clouds. Okay, so what you need to remember, this is the effect. It looks like a ring around a cloud. Okay, and the ring is of 22 degrees size. Bishop's ring is of 22 degree, and it is due to the diffraction. So why that happens is the phenomena is very important to understand. Okay, so this is happening due to the diffraction of light, and it happens in which cloud? Altostratus. So these are the three questions that can come. Now next is your halo phenomena, which also looks very similar to the bishop's ring, but it's different. So it has a red like reflective color. So this color here that is being reflected is like a reddish color. Okay, here it wasn't the same. Okay, so this is the major difference between the halo effect and the bishop's ring. Now in halo, what you need to remember is that there are two kinds of halo. There's a large halo that is formed and there is a smaller one. So this is again a question. So the large is, the size is 42 degrees and the smaller is similar to bishop's ring, that is 22 degrees. So what is the reflective color here? The difference major reflective color is red. Okay, in this halo phenomena, and this one is caused due to retraction. Very important. Okay, so retraction of light, and this was caused due to diffraction of light. These are the lights that we've already discussed. This was due to the inversion, and this was due to the lapse rate. Okay, inferior mirage and superior mirage. So that's it. I think that's all about the topic. So these are the questions which are again from IC Joshi. You can refer. They're very simple questions, direct questions. So now we're going to talk about clouds. So whenever, I've heard a lot of people say that clouds are the most difficult to understand. The reason is not it's difficult, it's just that it's too vast and you cannot remember everything. So the best way to study this particular topic is to refer to the question bank and then refer to the theory. Okay, then refer theory. So this way you would be able to understand what kind of questions are going to come for the exam, because we are focusing on the exam point of view, right? You know there are clouds. You would also, even if you read, you'll understand everything. But to remember precisely what needs to be, done properly for the DGC exam, so this is the best way to go in the reverse direction. We'll first refer to the theory and then to the questions, because I need to teach you a basic little items. But for you guys, just refer to the question, then refer to the theory. This will remember. All right. So what are clouds? Clouds are basically, you know what clouds are. They are condensed form of water in the air that causes a lot of things. And why we need to study? Because it causes what? Turbulence. Then it also leads to poor visibility. Okay. Then it leads to even rain or precipitation, you could say, right? And icing. So that is why to understand this is very important. Okay. Now clouds amounts are reported. So METAR is a report which gives you the weather of an aerodrome. Okay. So now the cloud amounts are reported in octas. Okay. And it is assumed that, what is it assumed is that it is assumed that the sky is divided into 8 parts. Okay, so this is how it is. In this image it's shown what is 8 octas, which is 3 octas, 2 octas. So if a circle is divided into 8 parts, so in METAR it's reported like this. Okay, so if it says SKC, that is sky clear, this is how it's reported in METAR in code word. So that means it's 0 octas, because there are no clouds at all. Okay, so it's clear, this one. When we say it's few, that is few clouds, that is 1 to 2 octas. When in METAR it's recorded as SCT, that is scattered. This is few. Okay, scattered, that is 3 to 4 octas. When in METAR it's shown as BKN, that is broken. These are just the full forms and short forms. That is 5 to 7 octas. And the last is overcast, that is basically fully covered. Okay, so now that is full 8 octas. The examples are given. So this is no blue sky, it's fully covered with clouds. So this is how it is. Now clouds are of 3 types. There are low level clouds, there are medium level clouds, and there are high level clouds. So these are the clouds that we're going to talk about. So these are the pages of IC Joshi that I've taken screenshots from. So the best way I told you is already, like, you refer to the question bank and then you come to the theory. But we'll just go and understand. So there are high level clouds. So what you have to understand in the questions, there will be short forms used. So you need to know what these short forms mean. Okay, so cirrus clouds, cirrostratus, cirrocumulus, these are all high level clouds. High level clouds, what we need to remember is that they are mostly consists of ice crystals. Okay, and only, but there is no icing, there is no risk of icing, and they are least dangerous. Okay, these are those clouds when you fly, if you've flown as a passenger, you would see those cotton like spreaded clouds all across, right, in broken clouds. So those are basically the high level clouds. Okay, so they are not dangerous, they are fine, they're calm, there's no much turbulence, and they have ice crystals, but there is no risk of icing or precipitation. They do not produce icing, not produce icing or precipitation. Okay, so this is high level clouds. Then we come to medium level clouds. When we talk about medium level clouds, now these are all here: altocumulus AC, altostratus AS. Now altostratus we read in the optical phenomena, right? The effect of optical phenomena, corona occurs in these clouds. So this is the question that could come. What is corona? Just go on Google and search corona phenomena. You'll see it's again like a circle around, So this is one. Then in altocumulus, you need to know that they're white gray clouds. They're composed of, you could just read through it. There are different types of clouds. Now there is Altocumulus lenticularis clouds. They are lens-shaped clouds. You can just Google and see the pictures. I have not put in pictures here. So they also do not cause precipitation, but they may cause ice accretion. So these are the lines that I'm marking. Just read that. That's enough for you to know which cloud has what. Then we come to the low level clouds, which are also the ones that you see there in the form of, fog, and these are low level clouds. So this is stratus cumulus, nimbus stratus. So the questions that could come is that they are clouds at a lower level. Yes, they do create drizzle. Stratus gives you drizzles. Okay, and for nimbus stratus, very important, their dark gray thick colored cloud causes continuous rain and snow. So a lot of questions would be asked on this. With a dark gray that causes rainfall are nimbostratus cloud. Then we talk about vertical development. These are basically the clouds that are dangerous. Okay. Plus it's a no-go. Like you're not supposed to enter these clouds if you're flying. Okay, so this is cumulonimbus clouds. Anything that's vertically developed. So what really happens in vertical development is, so their air keeps rising. Okay, and then that's the cloud that formed due to the vertical movement of air. Now these clouds are very dangerous. There's a lot of turbulence, there's rain, thunderstorms, everything's included here. So you have to avoid these clouds. Towering cumulus, I'll show you a picture in the end how they look like. So these are the clouds to avoid. They are vertical development. Clouds of vertical development are dangerous clouds and they are a no-go cloud. So that is all that you need to remember. Alright. And what is Varga? The definition is very important. I'll show you how it looks like. So basically the rain that is coming down from the cloud. So for example, this is a cloud. Okay. The rain that is coming down, and if this is the ground, before it even reaches the ground, this rain evaporates. Okay. It doesn't reach only. So I'll show you the picture also. So I'll show you all these pictures in the end. Now we have already learnt about the nacreous clouds and the noctilucent clouds in the atmosphere video that I had made, the first video. So these are the thing to remember here. These are the clouds that exist in stratosphere, and noctilucent are the ones that exist in mesosphere. That's all you have to remember. That's it. Now the last part of clouds is condensation trails. They are visible streaks of condensed water vapor formed in the wake of moving aircraft. So this image is for you guys to know how the trails look like. So this is how the trails look like. Okay, these are known as condensation trails. Moving aircraft, these are the trails that are formed. So what you need to know mainly as per the Met part is that there is a maxtra level. Okay. And there is a mintra level. With the name only you can see minimum and the maximum, okay, level. So these condensation trails are formed between that. So below the mintra level there are no condensation trails, and above the maxtra level there are no condensation trails. So they are only between here, mintra and maxtra level, the trails are formed. So this is it. And how are the trails formed? There's fuel, there's air, there's water vapor. So because of that you could just read how they're formed. It's not important, not a part. So in the exam point of view, so these are the questions that you need to see. These are IC Joshi questions. If you actually look at them, they're just 20 questions. Refer to the questions, go back and see what the answer is through the theory. If you just do this much for your clouds, it's enough for DGCA. Okay, just read the theory. We've already gone through low level, high level, medium level clouds. Now I'll show you the picture. So these are the cumulonimbus clouds. They look like this, somewhat like that. And you would see that they have a vertical development here, right? They look vertically high. So this is how they look like, and they're very dangerous. There are no glue clouds. This is high, medium. So this is a picture that I could find: low level, medium level, high level clouds, and these are the cumulonimbus clouds, which are a no-go clouds. Now this is known as virga. Okay, so there is a precipitation that's happening, but if you see, it's not reaching the ground. Let me change the color. So it's not reaching the ground. It's here and it evaporates on the way only. So there is no touching of the ground. So this is how virga looks like. We'll talk about virga, and we'll talk about microburst and macroburst in the thunderstorm chapter. Okay, so I'll be making video on that, so we'll talk about this in detail there. So yeah, that's all about clouds. It's not a very difficult topic, don't worry, you'll be fine. Just do the questions and just read through the theory once, that's all. Thank you for watching my video. I hope you learned something today, and I request you all to please subscribe so that I'm more motivated to make more such videos for you all.